So, an average adult woman has got a body surface area of 1.6 square meters. Suppose you needed to convert that into square centimeters. Why might you need to do that? Well, body surface areas are often used to determine dosages, and they're also used to calculate measures of kidney function and heart function. So sometimes you run into calculations like this. Now, a meter to centimeter conversion is no problem for us at this point, right? Because you know your prefixes. 1 centimeter, you know, is what? How many meters? 10 to the minus 2. Centi, lowercase c, is an abbreviation for 10 to the minus 2. So that would be no problem because I can see that's a link between meters and centimeters. But the trouble is I'm trying to link square meters and square centimeters. So how do I do that? Well, this is an equation. And like any equation, what you do to one side, you have to do to the other side. If I want square centimeters here, I can square everything on both sides of the equation. That will then relate square centimeters and square meters. Now what's going on here? 1 squared. 1 times 1 is just 1, so I could just rewrite this a little more simply. And 10 to the minus 2 squared. That means 10 to the minus 2 times 10 to the minus 2. Now since you know how to multiply powers of 10, tell me what I should write. 10 to the what? You add the exponents when you're multiplying things, so 10 to the minus 2 times 10 to the minus 2 is going to be 10 to the minus 4. So that's all you have to do when you're trying to convert powers of units. Now, if it's squared on both sides of the link you're trying to make, then you have to square both sides of the link. So here's my there's my link. I can do this in one step. 1.6 meters squared. Here's my link. I have to put meters squared on the bottom to cancel out meters squared. And it's got a 10 to the minus 4 sitting next to it. And I've got 1 centimeter squared there. So it'll be 1.6 divided by 10 to the minus 4. What's that going to be? 1 over 10 to the minus 4 is going to be 10 to the 4, so I can do that in my head. And that would be my answer. All right, you can also do this not just with areas, but also with volumes. So suppose I have a cubic kilometer of seawater. And I want to figure out how many milliliters of seawater that is. Alright, there is a conversion factor I gave you before that will connect volumes as cubed lengths with volumes in terms of liters. And here is that conversion factor. I gave you this the first time that I was talking about liters. Let's put a box around this because this is something you should know. So a milliliter is the same thing pretty much as a cubic centimeter. If I wanted to, I could just erase that and put cubic centimeters there. Because the answer will be the same. It'll be in milliliters as well as cubic centimeters since they're the same thing. So how do I do this? Well, it looks like I'm going from one prefix to another prefix. So I'm going to do basically what I was doing in the last worksheet, which is if I want to swap prefixes, I can take the first prefix off and then put the second prefix on. Now, how do I do each of these pieces? Now notice that I'm using powers of units here. It is no problem for me to relate kilometers and meters. Kilo means 10 to the 3, or 1,000. But how do I do cubic kilometers to cubic meters? Well, like I did before, if both sides of the length that I'm trying to make are cubed, I have to cube the length too. 1 cubed kilometer cubed is 10 to the 3 cubed meters cubed. Let's simplify that. 1 to any power is still 1. And 10 to the 3 cubed is going to be 10 to the 3 times 10 to the 3 times 10 to the 3. And when I'm multiplying powers of 10, all I've got to do is add up the exponents. So that'll be 10 to the 9. So there's my link for this one. Let's get one for this. Well, we've already done this, really. We know that 1 centimeter is 10 to the minus 2 meters, we said. What meters? So I'm going to have to cube both sides of that this time. Cube, 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 and cube. All right, let's simplify it. 1 cubed is 1. And so I've got 1 cubic centimeter is 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2. What's that going to be? Just add the exponents up. 10 to the minus 6. So, let me erase some of the junk on here. This is my link here, and this is my link here. Let's do the calculation. I need to turn this into a conversion factor. What should go on the bottom? Well, I'm trying to get rid of kilometers cubed, so kilometers cubed better go down there. There's a 1 sitting next to that. And on the other side of the conversion factor, there has to be 10 to the 9 meters cubed. Now I have another conversion factor to write down. I've canceled out the kilometers cubed. I've got meters cubed left. And I want to cancel that too, so I know that meters cubed has got to go on the bottom of this. So there it is. Can you do it in your head? It's going to be 10 to the 9 divided by 10 to the minus 6, which will be 10 to the 9 minus a minus 6, which should be, what, 10 to the 15? It's a lot of cubic centimeters. It kind of makes sense that that's such a big number because a cubic centimeter is very small and a cubic kilometer is very large. So if you cut a cubic kilometer, a huge thing, up into a bunch of small things, you're going to get a huge number of pieces. So it makes sense.